Hello everyone, we're going to do a quick review of logarithms. So hopefully you have some notes paper in front of you and you are ready to begin. So review of logarithms. First, definition of logarithm. If we suppose that b is greater than 0 and b is not equal to 1, we know that there is a number p such that the log base b of n equals p if and only if b raised to the p power equals n. This should be a review for you. You should remember how to do this, and you should remember this from logs. So I'm not going to be teaching you logs today, we're just going to be reviewing it. So for example, 2 raised to the third power equals 8. We want to write that in logarithmic form. So to do that, the solution would be log base 2 of 8 equals 3. Right? Hopefully you remember that. Another example, 2 to the negative 3 equals 1/8 in logarithmic form. It would be log base 2 of 1/8 equals negative 3. Alright, so now it's your turn to try some. So here are 3 for you to try. I'll give you a couple of minutes or a couple of seconds here to write them out. Okay, I'm back. So you should be done by now. So check your answers. You should have for the first one log base 7 of 49 equals 2, the second one, and the third one. Did you get them all right? If so, thumbs up for you. Alright, it's very important to remember to be able to start with a logarithmic expression and change this into exponential form. So this is just simply the reverse of what we just did. So if we have log base 3 of 81 equals 4, we want to write that in exponential form. We would write that as 3 to the 4th equals 81. Simple enough, right? Let's try one more. Log base 2 of 1/8 equals negative 3. 2 to the negative 3 equals 1/8. Alright, so you try these. I'll be right back. Alright, you should have these finished by now. Let's see if you got them right. First one, 10 squared equals 100. Of course it does. 5 to the negative 3 equals 1 over 125. 27 to the 1/3 equals 3. If you got all those right, golf clap. Okay, moving on. Example 5, solving some equations. If we have log base 6 of x equals 2, and we want to figure out what x is. So, we would rewrite the problem in exponential form. 6 squared equals x, so of course, x is 36. Let's try another one. We want to evaluate log base 3 of 27. Writing that as an exponential equation, we get log base 3 of 27 equals y. So if we rewrite it, 3 to the y power equals 27. We know 27 is 3 to the 3rd, so therefore y equals 3. Seems simple, right? Let's let you try some. Alright, we ready to try those? Hopefully those last two didn't give you too much of a problem. You would remember for number 3 that a common log is a log base 10, and an ln, a natural log, is a log base e. So for the first one, did you get x equals 3? Good job. Next one, x equals 1/3. Number 3, x equals 6. And the last one, x equals 12. If you got all those right, again, give yourself a round of applause. Moving on, consider some more examples. Without evaluating log of 678, we know the expression means that the exponent to which 10 must be raised in order to produce 678. So log of 678 equals x. 10 to some power has to make 678. Now, if 10 to the x is 678, what should x be in order to produce 678? Well, in order to solve this, we're going to need a calculator. So using a calculator, we would take the log of both sides. If you take the log of 10 to the x, you just get x. and then the log of 678, we can put that on the calculator and it will give you a number. You can also do this with natural logs. So if we're evaluating the natural log of 54, we would take the natural log of both sides, right? And if e to the x is 54, take the natural log of both sides. The natural log of e cancels and leaves the x on the left. Natural log of 54, put that in your calculator, it gives you a decimal answer. Here are some basic properties of logarithms. I'm going to play some music here and let you write these down. I'm back. If you haven't gotten them written down yet, press pause. Go ahead and finish writing them before you resume. I'm not going to go over these. You have them written down. They should be familiar to you. And so we're going to move on. We're going to use these equations to help us solve some equations using the basic properties. So for number 1, we have the log of x minus 3 equals 5. To do that, I'm going to raise both sides 10 raised to that power. Notice that the 10 in the log cancels each other out, so you're left with x minus 3 equals 10 to the 5th. And then you can just solve it. For number 2, it's a natural log instead of a common log, so we raise both sides e raised to the power. E and the natural log cancels each other out, and so you wind up getting that answer when you solve for x. Okay? Moving on to the next example, laws of logarithms. You should also be writing these laws of logarithms down. Remember that when you're multiplying like bases in exponential forms, a to the m times a to the n, well, that's just a to the m plus n. And when dividing a to the m divided by a to the n, you just subtract. Logarithms work the same way. If you have the log of VW, that's equal to the log of v plus the log of w. Natural logs, they behave the same as common logs. When you're dividing log of v divided by w, you get the log of v minus log of w. And again, natural logs behave the same way. So those are product and quotient laws of logarithms. You should definitely have those written down on your paper. To use those rules, if we know that the log of 3 is 0.4771, you can check that on your calculator if you don't believe me, but trust me, I have an honest face. The log of 4 equals 0.6021, we want to find the log of 12. To do that, well, we know 3 times 4 is 12, so the log of 12 is the log of 3 times the log of 4. And using our rules, we know the log of 3 plus the log of 4 would have to just equal to those two decimals added together. Also, down at the bottom, number 2, the log of 40 and the log of 8, we want to find the log of 5. We would know 40 divided by 8 is 5, therefore we can just do the log of 40 minus the log of 8 and we get that decimal. So that's one of the ways we can use the product and quotient rules. That brings us then to the power law. So when you have a power, log of v raised to the k, remember that the k gets moved in front. So you just swing it around and you put it in front. And once again, the natural log behaves the same as the common log. So for example, if we have the log of 3 squared, the 2 comes in front and we get 2 log 3. Using the power law. So if we know the log of 25 is 1.3979, we want to find the log of the 4th root of 25. Well, we can rewrite the 4th root of 25 as 25 to the 1/4. Then we can bring the 1/4 in front, multiply 1/4 times the log of 25, which we knew is 1.3979, and bingo, bongo, boom, there's your answer. And this one works the same way. We want to find the square root. The natural log of the square root of 22. The square root of 22 is 22 to the 1/2. Bring the 1/2 in front. 1/2 times your decimal, and you have your answer. We can also use this to help us simplify expressions. If we have the natural log of 3x plus 4 times the natural log of x minus the natural log of 3x times y, we want to evaluate this as a single logarithm. Hopefully this is seeming familiar to you. You did all this in Algebra 2. We can put all that together by first I'm going to move the 4 up above the natural log. Then, because it's addition, we can multiply the 3x times the x to the fourth, which would give us 3x to the fifth. Then, since it's subtraction, we can divide 3x to the fifth divided by 3xy. The 3's and the x's cancel out, and there's your final answer, the natural log of x to the fourth over y. And then we want to simplify each of these expressions. So again, we have the log of 8x plus 3 times the log of x minus the log of 2x squared. I'll give you a minute and let you try these on your own. I'm back. All right, so let's check your answers. For the first one, did you get the log of 4x squared? And what about the last one? 1/4? Huzzah if you got that. Well done.